Okay. We're going to work complex numbers. Okay. Especially with complex numbers, we're going to talk about irrational numbers. Okay. That's right, irrational numbers. Okay. And irrational numbers are essentially numbers we can't comprehend. Now, for instance, I cannot find the root of a negative term because, as far as we know, any two numbers, positive or negative, being the only two really types of numbers on the number line for whole numbers, -2 times -2 is +4. Let's write this in non-disappearing here. -2 times -2 we know is +4. And we also know +2 times +2 is what?
4.
+4. Neither of them create a negative. So for instance, we know if we were just have root 25, well, if it was just root 25, the answer would be 5. Not just 5. Technically, it's plus or minus 5. But we have a negative term. I can't create a negative term. So what we do is we are creating a variable to represent a complex number. And what we're saying is the term I, okay, can be square rooted or squared to equal -1. Okay, so we're saying I squared is equal to -1. In other words, we're saying some irrational number times itself will actually give us -1. It'll actually give us a negative term. So anytime we have a negative here, I can factor this out. Remember, we were just doing radical terms, so we kind of factor out the negative. Let's say we have root 25 now becomes +25 times -1. Okay, we know we can break that up. Well, we also just discovered, or we just decided to represent -1 with I root 2, or I squared, sorry, not root 2. So we can replace our -1 with I squared. So this question now reads the root of 25 I squared. Well, I can find the square root of I squared, okay? Just like we talked about before. Remember, here's an example. Let's use the number 3. 3 squared square rooted, okay? We can break this up in steps, but there's a fast way to do this. 3 squared is 9. Square root of 9 is 3, okay? So essentially what you say is our base, this square root and this power of 2, you could say cancel each other out. They kind of created 1. And we're left with just the base. So in other words, the squaring 2 and then square rooting it just leaves us, or not 2, I just leaves us I. And we also, what's the square root of 25? 5. So this is going to read 5I. Okay. So we're saying that the answer to the square root, we'll rewrite the question again, square root of -25. The answer to square root of -25 is actually 5I. I being some term that we can square to make -1. It's an irrational number. So what they've done with some of your work here is they've used it to represent, especially when we're in quadratic formula, different terms. But one quick way to show an example of this when solving something is, for instance, say we have a quadratic. We'll call this example 2. We have a quadratic and they've written something like x squared plus 36 equals 0. And we need to find x. Well, when we go to find x, we bring 36 over. We get x squared is equal to -36. And to get rid of our squared here, we need to square root both sides of the equation. Well, when we go about doing that, we're left with x is equal to the root of -36. Well,
it's going to be 6i.
Yeah, exactly. We don't have a rational number for that. So we replace the negative term with I squared, okay, because we talked about I squared now representing -1. And then when we square root that, we end up with 6I, okay? And because it's 36, it's technically plus or minus 6I, just like it would have been here, plus or minus our 5, okay? So that's the entire page for complex numbers.